A question that I often get is how you can optimize your MR and VR game, what tools are available, and how complicated that is to a non-expert developer. Well, today I am very excited to announce the release of the Meta Quest Runtime Optimizer, which provides you with an easy way to determine performance bottlenecks within your own app or game, and it works with any XR project. And even better, it has zero dependencies on Meta SDKs. Well, if that sounds exciting, let me show you how it works. All right, guys, so let's go ahead and get started, and I'm gonna show you here how we can set up the tool. But first, we're gonna start by creating a new project. I'm gonna choose the VR core project just to keep things very simple, and then just go ahead and select the location. I'm gonna put it here under code, and then we don't need to connect it to Unity Cloud. Then just click on Create Project. This is gonna be the project that we're gonna be working with. You can see that I have wireframe enabled. You can basically just click in here and toggle these different options so that you can see how many faces and vertices we have on all of these components. Like if you look at this ring right here, it's pretty heavy, and it also shows you if you wanted to look at the actual mesh, click on the ring itself in there, and then you're gonna see here that we have a ring, and then if you click on it, what I wanna show you is the total triangles that this component specifically has. This has 4,800 triangles. So that's going to be something that we need to be very cautious of. Another thing that you can also do is if you go into a game and look at the stats, this will give you the total of triangles and vertices that we have. So you can see 81,500 on this scene, and then also 50,500 vertices. So this is just a good number, a statistic to look at. So if we go back into the scene view, one thing that I want to show you though is I want to show you these in action. But before I do that, let's do one thing pretty quickly here. Go into build profiles, and then let's go ahead and switch to Android. All right, so this is the scene that we're going to be playing with. So if you look at some of these components, I can interact with them. And this scene is pretty optimized, to be honest. But there's different objects, such as if I go close to this one, for instance, this one we were looking at that had a lot of different triangles. Also, the ring that is around and rotating has a lot of triangles. We can go ahead and move some of these ones. And then the other one was gonna be that sphere that is sitting on the very top. That one was pretty detailed. And then the sky is pretty detailed on as far as the texture is concerned. So we're gonna be looking at compressing that one, but I want to show you how I know that, right? So before we set up the Meta Quest Runtime Optimizer tool, make sure that you watch this video until the end, because we're going to go through the process of getting a compiler that is required before we can show metrics on materials and shaders. So this is what you should expect after going through that process. So let's go ahead and continue on. All right, so if you want to download the Meta Quest Runtime Optimizer, make sure that you go to the asset store.unity.com, and then just search for Meta Quest. Once you search for Meta Quest, you're gonna get one of these packages in here. Just click on Meta, and then if you scroll down, you're gonna be able to find the package. Just go ahead and select the package. Then make sure that you add it to your assets. I'm just gonna go ahead and click on that. So once you add it, you should be able to click on Open in Unity. Just go ahead and click on that one more time. And it's gonna open the package manager. Let's go ahead and install it. All right, and now that should be ready to go. Now that we have it installed, click on Meta, Tools, and then Quest Runtime Optimizer. And it's gonna open up a pop-up in here, which is gonna be the optimizer itself. You're gonna have different instructions of what it is. What are some of the steps that is going to be needed in order for us to be able to use it. So just go ahead and click on Enable the Quest Runtime Optimizer, just like it says right here. I also have my device here connected via USB-C, which is what it's saying in here. And then it's also going to require that we create a build in developer mode. So to do that, just go ahead and click on Open Build Settings and make sure that you have Android as the selected platform. We did that initially, so you should be ready to go there. Also, it's going to require a development build, so make sure that you check that. And then also make sure that you select your Oculus Quest 3, which is the one that is connected via, I keep doing this, but it's actually located right here. And then once you do that, I think we should be good to go. And just make sure that that is checked, right? Now we can go ahead and create a build. Click on that, and then just go ahead and name it. You can name it anything you like, and then just click on Save. All right, guys, so I got the build deployed to my headset, so I'm gonna go ahead and click on Launch. And you're gonna see that it's gonna launch the game right from my Meta Quest 3. You can see made with Unity, so it looks like everything is running. The experience is running just fine. So if I were to grab the controllers, you can see that everything just works as normal, right? This is the build that we just pushed to a device. And what if we wanted to see the performance on this game? And that's where I want to get to. So what I'm going to do, though, is I'm going to go here where it says capture frame and also click on these three dots. So right now it's going to freeze the game when it's doing the capture. That way nothing else is happening when it's actually capturing the actual frame. So I'm going to click on it. Now we have this, and we can actually release the freeze that it's doing right now. And so there's two sections in here. The bottleneck analysis is going to give you basically possible graphic bottlenecks based on my target FPS. Right now it's running at 76.2, which is really, really good. And we also have a what if analysis that is going to scan all the different game objects. But before we look at that, let's go ahead and click on this bottleneck. And it's going to give us additional insights. So right now, it didn't find any recommendations that it could give us. And that's because this game, this template is pretty optimized. But I'm going to show you how we can change that to not be as optimized. But just a few things here on the render breakdown. You can see that the optimal number of draw call counts should be less than 300. We have 70, which is great. The MSAA, which is anti-aliasing, is set to 4. Vertex analysis is pretty cool. You can see that way here. We can see the dynamic objects, also different meshes, what the percentages are as far as impact, and then also the locations where those are. I can also go down here and look at the texture analysis. This is telling me that this texture, if I click on it, you can see it, that it pops up on the right side. That means that 31% of the 0.91 of the memory usage is being impacted by this texture. So we can actually save some memory if we were to compress it. I'm going to show you how we can do that. But you can look at all of these different textures. And if you click on them, it's going to tell you where they are. The same thing here with the different meshes. If I were to click on this one, which is 10%, it's also going to show you here the total count. So if we look at the total count, it's 12,800. Right now, we only see percentages, but you can change that by clicking on this and toggling use percentage. And now you can see that this torus is 6,561 as it relates to the vertices. You can also click on this other one here, and it's going to tell you this one is 12,480 triangles. So it just gives you really good information about how many triangles we have, how many vertices we have. And then if I click on here, and then you can also toggle the detail info if you don't want to see that. So I'm going to go ahead and just keep it as it is. So another thing that is really cool though, is if I wanted to look at the ptrace, this is also available. So if I click on it, it's going to open the Perfecto. And for those of you who are really familiar with Perfecto, you can still, use this tool. And then if I click on maybe GPU here, render stage, this is looking at the render stage for basically for the application that we just deployed, but it has a lot of different information in here. Another thing that is really cool though is I can also export this, and then I can say these are gonna be analysis, and then we can just go ahead and go into it, and then it's gonna save as a ROZ file. You can click on save. Maybe later on you want to delete it, and then you wanna keep track of those. But what I can do though is I can actually import that if I wanted to. And if I wanted to import it, for some reason, it's not showing that panel. So let's do this. I'm going to go ahead and do a new capture. And it's not displaying that panel right now. It might just be a bug. But we'll just run another capture so that we can get that panel back. And then I can do a new import. So it's going to take a few seconds in here to run. So now we can see this. So what I can do now, though, is I can click on import capture. And then I can double click on that. And now I have two captures, right? This one is going to be in descending order. This is going to be the new capture. This is going to be the old capture. And for some reason, the new capture is taking less. It's taking a bigger impact on frames per second. On this other one, it's a lot faster, but you can kind of see that we can also keep track of those and keep them in an archive if we wanted to look at a capture that we ran in the past. So another thing that I can also do though is I can scan all the game objects that are currently in the game. So it's going to go and run through that and find out, like it says right here, how much time it can be saved for each one of these game objects. And you can see here the ceiling is taking 0.825 milliseconds. And then all these objects also have their different milliseconds of how much it's taking. You can click on ring, and then it shows me what that is. So I'm gonna click on this one and I'm gonna look and see, okay, what can I do to improve the performance? Right now, this is taking a lot of memory and I don't really need it to be that detailed of a sky. So if we look at the sky right now, it's really nice, right? I can go in here and then look at this texture. It's gonna make this one a little bit bigger. This is gonna be the texture that we're gonna need to compress, and which is this one right here. So if I were to resize it, we can simply, so actually move this up so we can see the look and feel of the texture. I'm gonna go ahead and change this maybe to 512. And then as soon as you hit save, you're gonna see that that number in megabytes went down. So that is really important because if I were to run this game one more time, it's going to run with a lot less memory because the size of this texture is a lot less now. So I'm gonna go ahead and go back in here. And now we apply that to the capture and to the texture. So let's look at the capture one more time. And then I'm gonna go down in here and I'm gonna look and see what else can we optimize. And there's really not much to optimize because this is currently, a very optimized game. But what I'm gonna do though is this ring is used quite a bit in some of these different game objects. Like you can see here, this one is used. So what I'm gonna do is go ahead and look at the ring that I have in here. So what I'm gonna do is I'm gonna go ahead and uncheck this. And this is just an example, right, of what could happen if we were to optimize this. So this one is using PSphere 1. So if we go back in that, let's go ahead and look at PSphere 1 for that capture. And that's gonna tell you, about how much it's taking on performance. And if we look at it, PSphere 1 is taking about 10%. So what I'm gonna do though is, I don't want to add that interaction. And that probably won't be likely in your case that you can just remove things, but you could go into an application like Blender and then optimize your mesh. All right, so I just ran that new build and it's deployed to the headset. Just gonna go ahead and click on launch one more time so that we can see the game and it's connected to the actual runtime optimizer. Well, it'll connect to the optimizer, so it looks like it's connected now. So what I'm gonna do though is I'm gonna go ahead and capture a new frame. And if we look at the device, which I'm gonna look at it because I'm not recording, but it is freezing the current frame, which is good. So just give it a few seconds in here when I finish processing. And what I want to see is I want to compare the previous capture to this new capture. And we should be able to see here that time so that improved a little bit. I think like the one before, which was 7602. But let's go ahead and look at this one right here. And when you select it, it's going to give us the details. So we have 48 megabytes in here. And then, okay, so let's look at triangle count too. 106. So 48 megabytes and 106. So triangle count is a lot better on this one, and also the megabytes on the loaded texture. First, I'm going to go ahead and create a folder. Let's call it Meshy Models. And if we go ahead and go into my browser here, there's going to be some really cool different models that I selected. So if you look at this one, it's kind of like a futuristic portal. And it has a lot of different vertices and also faces. And if I click on it, you're gonna see that it's gonna be a little bit slower. Okay, looks like it's performing okay. There's a lot of different faces and vertices on this one. Also, if I were to look at this other one right here, this one has 88,779. If you look at the other one, was like 300,000. And then I also have this helmet in here, which is really, really bad in terms of how much detail it has, especially for a game that you're developing for Meta Quest. So what I'm gonna do though is in my case, I want to bring him in and I wanna show you that we can actually identify if these objects are okay, if we want to basically get a better version, a low poly version, how that's going to change the analysis. So what I'm gonna do is I'm gonna go ahead and download all of these. I'm gonna download them as OBJs. So right now I created a new capture and you can see that now we're half the frames per second versus what we had before of 76. Now we're at 32. And also says GPU bound, GPU 26.57 milliseconds. So there's something going on in there that it wasn't happening before, right? So let's go ahead and select it, and I want to look at some of the results. It tells you here, consider reducing the vertex count. The MSAA level needs to be smaller. Let's just pretend that we do need to do that, right? So I'm going to go into my URP profile, and I'm going to go ahead and make this value, or the value of the anti-aliasing, set it to 2x. So we're going to follow a recommendation. It's going to go from 4 to 2. And then the vertex data cost is really high. And we can see that because this number right here is super high. So another thing that you can look at is this is taking 21.5 of the weight in the vertex analysis. And if we look at it, we know that, right? Because it's at 739,564. The same thing with this other object. This one is taking, 645,044 triangles and so on. So we know that those are affecting performance. So if I go and look at these numbers right here and you compare it with the previous capture, you're going to see that the previous capture is a lot smaller. So if you look at them right here, you can see that these numbers are a lot smaller. So therefore, the performance, more likely, it's going to be better. All right, guys, so this is the new scene with the optimized models. I have the helmet here, which is now a lot better than the other one that had so many different vertices, and also the volts here are way optimized versus what we had before. And then I added this character here with the portal that we have here on the bottom. The other one didn't come out that good when I decremented the amount of triangles. So what I'm going to do though is I'm going to go ahead and build this and run it, and I'll show you a new capture of this scene. All right, it looks like everything looks good here. Less memory, less triangle count. We also lower the MSAA value, and also the draw call looks great. All right, guys, so we just took a look at triangle counts by using the Meta Quest Runtime Optimizer. But what does that number actually mean, and why do we need to keep it within a specific range? Well, it all depends on the underlying hardware. How much power do we have to be able to draw these many triangles? So if we're looking at a platform such as mobile AR, which is AR Foundation, ARKit, or AR Core, so you're targeting iPhone or Android devices, then the recommendation is to have 300K to 800K triangles. Meta Quest 2, 3, or Pro, 500K to 1 million triangles. Vision Pro, it's going to be very high because the GPU power that this device has, and it's also metal based. So 2 million to 4 million triangles. PCVR, on the other hand, can handle a lot more because you can have a very powerful GPU on a custom PC, right? Also, consoles such as PlayStation VR 2 can handle a lot more triangles. It doesn't mean that you don't have to worry about performance, you still do, but it means that you can have more detailed meshes in your game to allow you to check performance on shaders, and also different metrics that are calculated from your shader code. So to do that, we're going to go into here and then click on the 3 dots. And there's going to be an option called Enable Adreno Offline Compiler. So if you click on it, it's going to tell you here that you need to specify the path where that's going to be located. Well, I already created an account at Qualcomm.com. Basically, go to my account, Qualcomm.com, and then it's going to walk you through that process. Once you create an account, you're going to see a portal like this, and then you're going to be able to download what we need. So to do that, just click on this link right here, and that's going to take you to the right location to download this GPU offline compiler, which the tool that we're using is going to need. And then just click on download. Okay, so what we need to do is just right click on it, and then we're going to be extracting this. And just so you know, this is only going to be compatible with Windows as of right now. Okay, we can just click on next, agree, and then let's go ahead and install it. So we're gonna need to run a new build in order for us to check the performance on our shaders. So what I'm gonna do to do that though is I'm gonna download a new asset before we do that. So I got this shape in here with the water shader, and if you look at it, it has this component which is called example water 01, which is a material, and then inside it has a shader associated with it, which came with the asset, and it's called water volume URP. I went ahead and made a couple of changes. It looks honestly super beautiful, and you can see here in the game view that things are animated and moving. So what I'm gonna do though is I'm gonna go ahead and deploy these to the actual device so that we can test the material and shader improvement recommendations. So what I'm gonna do here is go down to the actual device and then make sure that it is selected as the headset that I have connected via USB-C. And then when it's ready to go, I think I have everything else correct. Click on build and run. I'm gonna go ahead and give it a Meta Quest build.apk. Click on save. So I got the scene loaded on my Quest device and you can see the water looks beautiful. Also everything it's performing, pretty good. I don't see anything with the delay. And I can also look at the objects that are behind the water. Kind of looks like they're under the water, which is really cool. I think that shader is amazing. Can also move the objects in here and everything just feels super fluid. Everything looks good, right? But we don't really know what's happening without actually running the profiler or running Perfetto. So what I'm gonna do though is I'm gonna go into my meta option in here and then the Meta Quest Runtime Optimizer. And we already looked at some of these options, but I wanna show you the new option that we just set up. So just click on launch so that we can basically kill the application from running and then relaunch it so that it gets connected to this tool. Okay, so it looks like it's good to go and it is connected and it is freezing the frame, which is fine. That's gonna give us a very accurate representation. Okay, so it looks like that completed. It's actually performing really well, even with the water shader that I just added is 76.25. Before the water shader, I had 76 and also 76.2. This one is an outlier because I added a huge mesh, so I wouldn't really count that as an accurate report. So I'm gonna go ahead and click on it. I'm gonna show you some of the metrics that we're gonna be seeing now. All right, so we're gonna get some insights in here. We also have the draw calls. Less than 300 is optimal, we have 7. The anti-aliasing is 2. 4K on the triangle count is pretty good. And then 45 megabytes is pretty good on loaded memory. I think we already optimized that as much as we could. And then if you look in here, we're now getting the material analysis results, which is really cool because we can now see which materials are getting impacted by performance. So this is analyzing the shader that is assigned to each one of these materials and then giving us these metrics. So in this case, we have everything in green. So more likely it's being, it's pretty good, it's optimized, so we don't really have to worry too much about it. So these numbers right here have different meanings. So this is gonna be for pixel shader count instruction. This is gonna be for vertex shader instruction, whether you're using floating point 16-bit math in your shader code, how many times you're reading a texture, and then also these other metric, pixel shader instructions, vertex shader instructions. Also, if you're dealing with the water, what it's considered a heavy number versus a light number of things that you shouldn't have to worry about. I'm gonna go ahead and click on capture frame. And I wanna see what kind of metric results we get this time, specifically with the water shader that we just added, right? So if I click on it, we should see the results now. So I'm gonna go ahead and go down. And you can see that we now have things to be concerned. It doesn't mean that it's not performing okay. Looks like it is performing fine, but this means that we have room for improvement on our shaders, right? We can see here that this interactable white is taking a hit on the pixel shader instruction, and then everything else looks fine. If we look at the wall cut, this one is taking a hit on that as well. The interactables 4 and then the water I know why, it's pretty heavy probably on the GPU, but you can see here is 669. And then 103 on the vertex shader instruction, and then everything else looks good. This part is actually pretty good. Looks like we're using the floating point 16-bit math, and this is telling us that we are. And then we also have probably an issue here where we're reading too many times the actual textures. Well, make sure to get the Meta Quest Runtime Optimizer from the Unity Asset Store. I would love to know your thoughts about it. Let me know in the comments below if this is something that you're excited to try, and be sure to subscribe, and as always, hit the notification bell to get notified of future XR videos. Thanks everyone, and happy XR coding.